Standards Practice Week 18. Number 1. Factor the following polynomial. So, if you have forgotten how to factor, a great test-taking skill is that you probably remember how to multiply polynomials. So you can use your distributing method or the box method to actually figure out what the answer is. So you can multiply each one of these out and see which one equals this, or you can factor it. So let's try factoring. I know that A is 5, B is 27, and C is negative 18. And one method we used was figure out what multiplies to make whatever AC is, but adds to make what B equals. So if I did A times C, which is 5 times 18, which is 90, and it's going to be negative, but it should add up to be 27. So I can actually figure out what numbers go into 90. So I can 1 in 90, one would have to be positive, one would have to be negative for this to work. But there's no way I could get 27 from that. I could do 2 and 45. I know that 9 and 10, that's not going to give me 27. If I did 3 and 30, oh, look, 3 and 30 can get me to 27. In order for it to be a negative, one of these has to be negative. In order for it to be 27, and it's positive, that would mean the 3 would have to be negative. So negative 3 times 30 is negative 90, and negative 3 plus 30 is positive 27. So I'm going to rewrite this, but the middle term is going to change. So 5x squared, and the negative 18 is the same. But instead of the 27x, I'm going to put negative 3x and plus 30x. And I'm going to factor by grouping. So I'm going to factor this together, and I'm going to factor this together. So the greatest common factor out of this is an x. And I'm left with 5x, because 5x and x make 5x squared. And then x times what gives me negative 3x? Well, negative 3. If I need to factor something out of here, the biggest number that goes into both this and this is a positive 6. 6 times what gives me 30x? Well, 5x. And then 6 times what gives me negative 18? Negative 3. And if you recall, as long as these match, I could pull those out. So I'm left with 5x minus 3 as one of my terms, not necessarily my first. And then what's left over is my second, so x plus 6. So you could see it this way, or you could see it written the other way, because the order in which you multiply numbers does not matter. Number 2, name the degree of the simplified form of the expression seen below. Type your answer in the space provided below. So I want to know, if I were to multiply this out, what would be the highest exponent? Well, I really don't need to, because the highest exponent it could have is this, and I know I'm going to multiply x 3 times, so this is a cubic function. So name the degree cubic, like C-U-B-I-C. Next page. Refer to the figure shown here when necessary. Leave answers in terms of pi. So I have this circle, and it kind of looks like a rectangle where the width is the same as the diameter of the circle. So let's look at what they're going to ask. Which expression below represents the entire area of the rectangle? Remember, area is length times width. So I just want to know what this times this is. Well, that's easy. You just do 2x plus 8 and x plus 4. So the circle has nothing to do with it at this point. So you can either choose to double distribute, or you could use your box method. So let's try the double distributing. So if I do 2x, I want to times it by x. And then I also want to do 2x times the 4. And then I want to take the 8 and times it by everything in here. So 8 times the x, and then 8 times 4. So 2x times x is 2x squared. 2x and 4, that's 8x. And then 8 times x is obviously 8x. And then 8 times 4 is 32. This is almost done. You have to add your like terms, so 8x and 8x. They do not cancel out because they're not opposite signs. So make sure you take that into account. All right, number 4. What is the expression in standard form of the area of the circle? Area of a circle is pi r squared, so I need to know what the radius is. So looking at this, if the diameter all the way across is 2x plus 8, that means my radius, which is this part, is only half of that. So half of 2x plus 8 is 1x plus 4, which happens to also be this way. You can look at it either way. So the height of the rectangle is also the radius, or halfway across the diameter. So let's look at what it asked again. So it said area of the circle. So if it's x plus 4, so pi, and then r is x plus 4 squared. So pi r squared. So I need to distribute this out. I'm going to leave pi off to the side right now and then take care of this x plus 4. Okay, so you're going to double distribute. X times x is x squared. So that's what I did first. And I'm going to do x times 4 is 4x. 4x times 4 times x is 4x. And then 4 times 4 is 16. And I still have the pi outside. So I need to combine my like terms and then times pi to everything, and that will give you your answer. Number 5, which expression would correctly identify the area of the shaded region? So if I'm looking at the shaded region, that's the outside of this rectangle. So the rectangle minus half of the circle. So area of the rectangle minus the half area of the circle, so the semicircle. Oops, semicircle. The area of